All right, let's just dive right into it. The GATE physics exam. We all know it's one of the toughest, most competitive exams out there. But what if I told you there's a clear, strategic path to cracking it? Well, today, we're going to map it out, step by step. And look, I totally get it. You open up that syllabus, and it feels like you're staring at an entire library of physics textbooks, right? It's massive, it's intimidating, and it's so easy to feel completely lost before you've even started. But here's the secret that most people miss. This is not about knowing everything. It's about knowing the right things. The real key to cracking GATE isn't just about hard work. It's about smart, targeted work. It's all about focusing your energy where it's going to deliver the maximum impact. And that impact, well, it has a number, 50 plus. Getting over 50 marks can be the difference between a good rank and a great one. And trust me, it is absolutely achievable with the right strategy. So let's break down this 50-plus mark strategy. We're going to take that overwhelming syllabus and turn it into a clear, manageable roadmap. How? By analyzing the exam's patterns and grouping every single topic by its strategic importance. So here's how we simplify the whole thing. We're going to group the syllabus into 3 strategic tiers. First up, you've got the heavy hitters. These are your absolute top priority. Then the solid supporters, to build on that and really secure your score. And finally, the finishing touches, to give you that all-important competitive edge. Okay, let's start with the foundation, the heavy hitters. These are the subjects that consistently carry the most weight in the exam, and mastering them is, well, it's non-negotiable for a high score. And here they are: quantum mechanics, electrodynamics, and mathematical physics. Now get this, each one is worth up to 12 marks. That means, together, they can make up over a third of the entire paper. These are your big 3, your top priority. So for quantum mechanics, you've got to zero in on these concepts. Solving the Schrödinger equation is absolutely fundamental. Same goes for understanding angular momentum and the hydrogen atom. And you really have to pay close attention to approximation methods like perturbation theory and the variational method. They are a super frequent source for questions. Now, in electrodynamics, Maxwell's equations are the heart of literally everything. Master them. From there, you build out your understanding of EM waves and waveguides, and hey, don't forget the related topics of special relativity and Lorentz transformations, which get tested pretty often. And finally, we have mathematical physics. Think of this as the toolkit you're going to use to solve problems across the entire syllabus. A strong foundation here is just essential. You need to focus on vector calculus, complex analysis, linear algebra, and of course, Fourier and Laplace transforms. These are the tools that are going to build your score.
All right, with that foundation laid, it's time to bring in the solid supporters. These are the subjects that will lock down your score and push you well past that 50-mark goal. Just take a look at this. Each one of these subjects consistently brings in about 8 to 10 marks. They are reliable, they're predictable, and they are incredibly valuable for making your preparation robust and really well-rounded. In classical mechanics, the focus is really on those advanced formulations. You have to master the Lagrangian and Hamiltonian methods. Questions on central force problems, small oscillations, and canonical transformations? Yeah, they're very common. Now for thermo and stat phys, you've got to know the laws of thermodynamics inside and out. The partition function is a super central concept, and you must be rock solid on the differences and applications of Bose-Einstein and Fermi-Dirac statistics. Next up, solid-state physics. Now, this subject actually carries more weight in GATE than in other exams like NET, so it's a big deal. Focus on crystal structures, the concept of the reciprocal lattice, band theory, and the magnetic and dielectric properties of materials. And finally, in this tier, we've got 2 key areas rolled into one. In electronics, your focus should be on the fundamentals of diodes, transistors, and especially operational amplifiers, or op-amps. Then, for atomic physics, make sure you have a firm grasp of atomic spectra, particularly for hydrogen, and the principles behind lasers. These are recurring, high-yield topics. So, you've built the foundation and you've secured the core. Now it's time for the finishing touches. This is where you gain that edge and really pull ahead of the competition. This last piece of the puzzle is nuclear and particle physics. Now, it might seem like a smaller chunk at 6 to 8 marks, but really think about it. Those marks can make a huge difference in your final rank. So for these final crucial marks, you're going to focus on a few key areas: the basic nuclear models, the principles of radioactive decay, and particle classification within the standard model. And in every single problem, you have to always pay close attention to the conservation laws.
So, we've identified the high-yield areas, we've pinpointed the specific topics. Now, let's put it all together into a simple, actionable game plan.
Here it is, your game plan broken down into 3 simple steps. Step 1, you're going to go all in on quantum, electrodynamics, and mathematical physics. I mean, master them. Step 2, you broaden your base. You secure those reliable marks from the solid supporters. And then, step 3, you add the finishing touches to push your score right over the top.
The path is clear. That syllabus is no longer some overwhelming giant, but a series of strategic targets. The code has been cracked. The map is right here, in your hands. So the only question left is, are you ready to begin?